All right, good morning. Happy Wednesday. Hopefully, you guys are doing all right. Um, Today marks the last day of actual assignments for this week. So, we only have two assignments this week. Not too bad, right? But that being said, this is kind of a large ish topic. That's why the last video was a little bit longer, and this one is also going to be a little bit on the long side, but I'll try to keep it short. Don't worry about it. All right. So, what we're doing today are transformations of quadratic functions specifically, or just functions really. But we're going to look specifically at quadratics. Okay, so yesterday we learned about vertex form. You know, if it moved up or down, right, you just added or subtracted the number at the end. If you moved it left or right, then you had to put it in the parentheses and you had to do the opposite of what you wanted to do. So that's what we're doing today, kind of in a more formal manner. So translation, all it is I'll use blue marker for translations. So translations are just going up, down, left, and right. Left, right. So I don't know. Yeah, we'll just do that. So up, down, left, right. And that's all the transformation or the translations are. So if I have, I'm going to erase this actually because it's kind of in my way right now. I'll just use arrows to denote this. So something like this. Up, down, left, and right. All right. So we're always going to compare it to our base, our parent function. This is the home base that we always come back to, right? That is just our f of x equals x squared. That's all it is. That's all it is, right? Translations, what we said or what we described yesterday, is if you move it up. So I'm going to use a red marker to kind of denote a new function. Something like this. So we've got our x squared, our base, our parent function. And then I moved it up to this red parabola. All I did was move it up because, remember, all you're looking at is the vertex, right? That's all you're looking at. How did the vertex move? And you see that all I did was move up. Well, we know from yesterday that means all we have to do is add it. Let's say this is 2, so plus x squared plus 2. Right? If it moves up, all we have to do is add how much it moved up at the very end of the function. So that's how you would have seen it yesterday. There's another way to see it, okay? If you want to generalize it to all functions, what you're going to see is something like f of x plus 2. What does this mean? It's saying, well, I told you that f of x is equal to x squared, so they're the exact same thing. These two are the same. That's what an equals sign means, right? So in this case, I'm really doing, I know I'm doing x squared plus 2 from yesterday, but since f of x equals x squared, they're the same thing, right? I'm going to replace this x squared with f of x. So these two are saying the exact same thing, right? But you're going to see it in both forms. So you just have to be aware and know how to translate between the two. Okay, so it's just a skill that we'll continue to work on, right? But that's translating up and down. Let's see how we would do it if we were translated left and right. So I'm going to start with my base function, like always. Always start with that parent function, the parabola. And of course, we start with f of x equals x squared, because that's what the function is, right? And then let's use green. And I said I was going to move it left and right? So let's move it to the right. We'll have a function like this. in green. So you see we start here. Remember, we're looking at the vertices. And then we're looking at the vertex of this one. How did the vertex move? It moved from the origin and then to the right. We know from yesterday, if you wanted to write this function, if you're moving left and right, you have to put it inside the parentheses, and you have to do the opposite of what you think it will happen. So I have parentheses, x, and then now I think it's going to be plus, let's say 3. Right? I think it's going to be plus 3. But if I'm in the parentheses, I have to flip the sign. So instead of plus 3, it has to be a minus 3. And then don't forget that squared on top. And that's kind of what we did yesterday, right? Now, let's put it into function mode, kind of a function notation, right? So I said that f of x was equal to this, right? Now this one's a little bit different because x squared isn't explicitly stated in this one. X is kind of separated from its squared by that minus 3. So here's actually how we might work this one out. Well, you see there's a parentheses in this one, right? And there's a parentheses in f of x too. And if you see that f of x, well, that's in the parentheses, and then that means whatever's in the parentheses is squared, right? So in this case, that actually means I can do this. F of x minus 3. So essentially all I did was whatever I saw in the parentheses of this one, I put in the parentheses of the function itself. So I have f of x equals x squared, then I've got the x minus 3 squared, and then that becomes f of x minus 3. So pretty much rule of thumb, whatever stays in the parentheses will stay in the parentheses. Whatever is outside the parentheses, it's going to stay outside of the parentheses. And that's kind of that rule of thumb. So that is translations in a nutshell, right? I can combine these, of course, and we'll go over a little bit of that at the end. But let's go on to some reflections. Now reflections they're kind of the easier one in my opinion because it's only either or. So only one of these will happen. There's only one thing to remember, and that's just the flip. Now, another thing to make sure that you know is that when you flip it, you're flipping it over the x-axis. It's always over the x-axis. We'll see reflections in geometry where you're flipping over different axes, but we won't see that for Algebra 1. You could. I retract that, sorry. But for our purposes today, we're flipping over the x-axis. All right, so I'm going to draw my coordinate plane just like normal. I'm going to draw my parent function, and same thing as normal. I'm going to start with that f of x equals x squared because that's what I'm starting with. Remember, I'm always starting with that parent graph, right? Now, reflections. Well, it says flip over the x-axis. Well, what does that really mean? Well, this is the x-axis right here, this line right here. So I'm going to flip this all on its head. So what it's going to look like, what the reflection should look like, is the same thing. Just you turned it around 180 degrees. If you see though, the vertices of both of them, it never moved. So you're really just pivoting it on its side. So you're not really moving it like a translation would, right? You're not moving it up, down, left, right. You're just flipping it. It's kind of like taking a quarter, if I can find one. Or we'll take one of these bottle caps, right? I can rotate this one, but it's not really moving anywhere, right? That's part of what reflections are. So that's what we've got. Now the easy part is yesterday, all you have to do is put the negative all the way in front. Well, since you put the negative all the way out in front, you can just do negative f of x. You just put it in front. That's it. Not too bad, right? Nothing else to really discuss there. Yeah, from what I can see. But here might be a question. Let's see. Well, Mr. Chung, what if it was on the inside of the parentheses? So what if I had something like f of negative x? Ooh, that's a good question. Well, what we can do is, let's see, we have this f of x equals x squared, right? Well, that means for whenever I see an x, I'm going to put in negative x with that parentheses, right? So I've got the parentheses, negative x squared. Here's the thing. And this goes back to kind of some arithmetic, right? So if I had negative 4 times negative 4. Now, you might be telling me the number right away, but this is also really just negative 4 squared. Whoops. Negative 4 squared. Right? There are two negative 4s being multiplied, so I can make it negative 4 squared. But a negative times a negative, that's a positive. So I have a positive 16. That is kind of interesting. So the problem with this function, especially the x squared function, is that f of negative x is the exact same as the original function. So if you have a negative on the inside of the function, for quadratic equations, it's going to turn out to be the same. And let me see if I can find a I'm trying to find one right now. But essentially, what happened with this one is that instead of flipping over the x-axis like we usually do, right? So you'll flip it down. This one, you're flipping over the y-axis. So you're flipping it the other way. But if I flip this to this side, it's going to look like this. Whoops. I can draw a better arrow. And then if I flip the left side onto the right side, they look the exact same. So that's another way to kind of visualize what is happening with that. Now, of course, this doesn't happen in every case. I'm just kind of going on a tangent here, but that's okay. Let's do another reflection. Let's actually see if I have... Yes. Awesome. So, I've got this little contraption right here. It's called a mirror. So that'll help me draw my reflections. So, let's get, whoops, we're on reflection, so we're still using the green marker. So I've got my coordinate plane going. This is kind of a little extra for those of you who are just curious about reflections. And you'll see this a little bit more in geometry. So that's where I'm trying to get us to go. Right? So if I've got this one, this parabola right here, right? So I've translated it to the left and a little bit up. And I want to convey to you f of negative x. Okay? What I can do, I can set this. I'm reflecting over the y-axis. What I can do is take my right hand. This kind of stinks because I'm left-handed. And I can trace my parabola. It's not going to look perfect because I'm left-handed. So that is what my reflection should be. I'll use a different marker for this one. There we go. So in this case, it actually isn't the same parabola because it's not resting on that y-axis like before. So in this case, it would be a little bit different. And if I did say something like, let me write this in red so you guys understand. This one looks like f of negative x. So this is flips over the y-axis. And then I'm going to flip it over the x-axis. And I'm going to use a blue marker for this one. So that's going to be the negative f of x, like we saw before. All right, so I'm going to go ahead and put this here. I'm actually not this tall, but I can still see a little bit. All right, so that's my reflection over the x-axis. There you go. That is reflections for you. If it's inside the inside the parentheses, it's going to flip over the y-axis, right? And if it's outside the parentheses, it's going to flip over the x-axis. So that's kind of where we would go for reflections. Yeah, I was hoping to get you guys to use these this semester, but unfortunately things happen. But it's all right. It's all right. So we'll go over dilations. As you guys can see, my brain is everywhere right now, so I apologize, but thanks for being patient. All right, dilations and stretches. Now, this one is strange, to say the least. Let me get something that might help. All right, so what I've got is a shirt here. This is a jersey that I used to have for Breast Cancer Month. And there's my jersey. There you go, number 13. And let's take a look. What we're doing is stretching. I'm going to be stretching this shirt out. And you're going to observe how I stretch it. So we're taking a look. I'm going to stretch it sideways, right? If you can see, it's getting wider as I stretch it sideways. If I'm stretching it horizontally, everything gets wider. If I crunch it up, right, it'll still get a little bit taller. So if I stretch it vertically, it's going to get taller. If I stretch it horizontally, it's going to get wider. That's what we're doing for stretches and dilations. So, how do we see that in math? Well, all right. So we've got this. I've got my parent function, just like normal, f of x equals x squared. All right, so let's talk about putting numbers on the outside first, right? So I subtracted on the outside, I did the negative on the outside. Now I'm going to do multiplication and division on the outside. So let's say I have something like 2 times x squared. What is that going to do? Well, since it's bigger than 1, it's going to keep getting bigger and bigger and bigger and bigger, right? So what that means is 2 times x squared is really just 2 times f of x. And when it's on the outside and it's bigger than 1, that's when it stretches vertically. The numbers on the outside always talk about vertical. So if we continue on with that, so the number on the outside is vertical. And here's the difference in language, okay? If it's bigger than 1, bigger than 1, then you're going to have something called a stretch. That's what I was doing with the t-shirt, right? I'm stretching it vertically. All right? If it's smaller than 1, it's going to be, there's a lot of different names for this one. Same thing with either one. There's sometimes they'll say dilation, sometimes they'll say magnification. Same thing with compress. They'll say compress, get smaller, stretch. It's kind of like a reverse stretch, really. But I think those two are the most common words you'll see. Compress means you're making it smaller, right? You're kind of compacting it. That's what smaller than 1 is. All right, so that's only when it's on the outside. On the outside. All right, so what would this look like? 2 times f of x would look like this. I'll use it. I keep forgetting to use a different marker. Here we go. We'll have a red-green looking thing. That's what it looks like. It looks a little skinnier, right? And it looks a little taller. It's getting bigger, faster. That's what you'll see visually. So let's take a look at what if the number was on the inside of the parentheses. So let's see. I kind of want to erase it. I kind of don't. But I need some space. I'll leave this up here for a second. Well, I talked about vertically stretching. So naturally, I'm going to talk about horizontal stretching. So I've got my parent graph, f of x equals x squared. Remember, we're starting with this one because we're looking at quadratic functions specifically today. So we've got this one, and we're going to put a number on the inside of the parentheses. So I'll have something like, remember it's a parentheses, x times 4 squared. X times 4 squared. Now, here's the thing. With x times 4 squared, you can really just rewrite it as 4x squared. It's completely fine. And to see it in a function part, you would see it as f of 4x. Remember, what's on the inside of the parentheses stays inside the parentheses. So that's what you would be seeing. And this is for, let me use a different number, or a different color. This is for the number on the inside. Well, for the number on the inside, we're talking about horizontal. Horizontal means left and right, so like this, a flat line. That's what we're looking for. And if I bring out the t-shirt again, it's going to look like this. We're stretching it out, right? If you see, the t-shirt is getting wider because of that. So, if it's getting wider, my picture, my new parabola, should now look like this. Interesting. So in that case, if it's bigger than 1, you're going to stretch it again. You're stretching it. If it's smaller than 1, again, you're compressing it. And that's pretty much it. Let me check that real quick. Oh, and I'm sorry. That's the opposite way around. Good catch, guys. Good catch. Awesome question. So, the question you should have asked, or would have asked, or did ask, is, Mr. Chun, since it's inside the parentheses, doesn't it do the opposite of what you think it might do? And you are absolutely correct. So, it's actually the opposite of what I just said. I'm very sorry about that. What you're looking for is actually compress on bigger than 1 and a stretch on smaller than 1. Now, the parentheses rule, that's one way to remember it. But another way to check it out, how I checked it to make sure that I was correct, just take some numbers, right? And you can make a table. This is kind of extra. So I'm going to make a table, and I'm going to look at the points of each one. All right, so for this one, I want to take a look at this one right here, 4x squared. So if I do 1, oops, if I can even write 1, there we go, 1, then it means 4 times 1, that's 4, squared. That's 16. That's really high. That should be like all the way up here, right? Something all the way up there. Now let's try 2. Well, 4 times 2, that's 8. But then squared, 8 squared is 64. And that's all the way up here. I don't want to draw on my wall. So it's just up here somewhere, right? And if you would keep going, right, negative 1 is 16, negative 2 is 64, right? You would actually get a parabola like this one. Okay, so if you can see from this one, this new one that we just made, this is actually compressing it, right? It's stretching this almost vertically, almost, right? Because we're kind of squishing this horizontally, it has no choice but to go upwards in that case. So that's how I knew, because 4 is bigger than 1, right? So that's why it has to compress here. So that was my thought process on why I was able to recheck my answer and figure out that it is in fact the opposite. Of course, you could have just remembered the parentheses is the opposite in operation of what you think it might be rule. But there's always a lot of different ways to check. Another way to check, use Desmos, right? If you go to desmos.com, right? I'll write that right down here. desmos.com. Right? You can check that out, and you can actually type in f of x equals parentheses 4x squared. And it'll give you a very, very tiny, not tiny, but a very tall function. Well, all of them are kind of tall, but visually, it's a horizontally compressed function. So that's what we're looking for today. So that is my think aloud. That is my process through going through each one. You can definitely skip around if you like, if you need some review. I know this one can be a little confusing, but just always think back to the t-shirt, right? Always think back to this t-shirt. If it's inside, then you're going horizontal, right? Just like translations. Translations, if you're going left and right, it's inside the parentheses. So that's one way to remember it. Left and right, inside parentheses. Because you have a left parentheses and a right parentheses, that means you know you have to go left and right. And then you've got the up and down, of course. So just don't, you can always refer back to this video. You can always look at other resources. I probably will link some other resources. Khan Academy is awesome. But I believe this should be all you guys need for transformations of quadratic functions. If you guys have any questions, don't hesitate to ask. And you guys have an awesome day. I'll see you guys later.